Hi everybody, just a reminder today that besides this Ed puzzle, please make sure you've signed in to the Google form and listening to this Ed puzzle through at least the first question and doing the Google form marks you for attendance, but then also for full credit. Please make sure you finish this Ed puzzle today and then also start the IXL. Honestly, there's no reason most of you shouldn't be able to finish it, and those of you who not finish it should be able to get into the 60s, 70s, 80s, even if you're bouncing back and forth. But if for whatever reason there's somebody who gets into the 20s, 30s, 40s, and you're bouncing back and forth, that's still enough to then finish it later this week and get full credit. If you're stuck, you can always ask next class. I know it's a little hard trying to do this stuff on your own. Anyway, some quick review things here from triangles that we're going to have to use for rhombuses today. How do you find the missing angle of a triangle? Well, you find the missing angle by using the total number of 180 degrees in a triangle. 180 minus 27 minus 46 comes out to be 103 degrees, so that obtuse looking angle right there is 103. What about an isosceles triangle? Well, try to do the same thing. 180 minus 34 gives you 146, which is a number for an obtuse angle, and there's no obtuse angles in this triangle. So what do? Well, since it's an isosceles triangle, then that only has two sides congruent, but also has two base angles congruent. This is when we divided by 2 and said, okay, 146 is the total, 73 degrees is each of those angles on the inside. For your first Ed puzzle question here, how do you find the missing angle in a right triangle? What makes sense to do? I'm going to pause here for just a moment here and let you guys choose an answer. And the answer is, again, start from 180, of course. Subtract from 68. But no, don't just only do that. There's a box symbol in the problem. That means 90. So you have to subtract, just like the first problem, 180 minus both the other numbers, even though 90 is not in there, the box symbol counts. And you get an answer of 22 degrees. That's how much that small little symbol is right there. Okay, we're going to be doing this math. We're going to be subtracting from 180, including with right triangles. We're going to have to know this fact about isosceles triangles. But let's go back and now review what we did yesterday about rhombuses and parallelograms, because the first thing is, remember that rhombus is a type of parallelogram. So first thing here, the opposite sides are parallel. They're going the same direction. Same in the rhombus below. Opposite sides are congruent. They're the same length. Same and even more so in the rhombus below. Bottom left angle congruent to top right angle. Top left angle congruent to bottom right angle. Also true in that rhombus. Consecutive angles supplementary. That's the two angles here and here add to 180. Same thing in the rhombus below. And then the diagonals bisect. If you have one long diagonal and one short diagonal, the two pieces on either side are the same, whether it's on the top left and bottom right or the bottom left and top right. Everything of those things is the exact same thing true in a rhombus as well. The rhombus then has additional properties. It's equilateral. Not only is the left side equal to the right side, but also the top side equal to the bottom side. The key thing about a rhombus is all four sides are equal. When you draw the diagonals like a parallelogram, you have a short one and a long one. But unlike a parallelogram, the angle in the middle is a 90-degree angle. It's not going to be 88. It's not going to be 93. It's not going to be any other number. The angle in the middle has to be 90. The vocabulary word for two lines intersecting to make a 90-degree angle is perpendicular. So let me put that in here really quick. It's sort of messy. And then lastly, the diagonals bisect the angles. You have to make sure that in a rhombus, at every corner, different than parallelograms or rectangles, the two pieces are equal. Like on the bottom left, the two pieces are equal. On the top right, the two pieces are equal. In a parallelogram, one of those pieces, the whole angles are equal across from each other. Not only in a rhombus are the two angles equal, if you split the two angles, all four angles are equal. All right, take a look at the bottom left. This will be your next Edpuzzle question here. How big is AD when you see the number 12, the little box symbol in the middle, the 51 degrees? How do you find AD, this side here on the left? Hopefully you got it right. All the sides are congruent. That was the key thing just a moment ago. This side on the left, congruent to the right and to the bottom, and most importantly, congruent on the top. AD is just 12. There's no math to do. So on this next one here, it should be pretty obvious to set them equal. After you set them equal, you should know how to solve. I'm not going to do a huge amount of Algebra 1 solving, but because we have a couple students in one of my classes, maybe in the other, not all four classes, who are still struggling with this Algebra 1 solving, I'll do this much here. At this point here, you should have a two-step equation you should know how to solve. Sorry, I'm out of room here to write. You should be able to get x is 24. Just be careful, 24 is not the final answer to the question. The final answer to the question is find CD, and IXL today very rarely will ask you to solve for x or solve for y or solve for the variable. It will, but not most of the problems. Most of the problems they'll ask you to do is like finding CD. Well, CD is blank, but like the last problems, all the sides are the same. So plug it into whatever part you want. 7 times your answer of worked out to be 24. You're going to just plug in your answers to the end. My CP classes, this is stuff you've done a lot recently. My AC classes, you have done this, not just a ton in this class back from first semester, but you've even done this a couple times recently. Just not as much as my CP classes have, but you have. You did IXL level endpoint 6, and we did this in our notes, so it's not. So first thing on this page, reviewed the parallelograms, reviewed the rhombus properties from yesterday, and showed that the sides are equal. Set them equal, and to find something after you plug it back in, things might be equal. Third page here. A lot of your questions on rhombuses are going to be yes-no questions. Does it match up with the markings on the first page? There will be some that are algebra questions with sides, like that page where you have to make sure you set things equal. Then there's going to be ones which look like this. It gives you an angle, and whether it asks you to find the angle on the left or solve for a variable on the right, you're going to have to do 180 work. So, like we did on the first page with triangles, if you're trying to find the missing angle in a rhombus, and it's an isosceles triangle with two sides the same, you subtract from 180, and then you divide by 2. We did this on the first page of notes. We're doing it again. That angle there is 34. And if you trace TVU, this other angle on the other side is also 34. It's not very hard to do this. You just have to know when there's one diagonal. Look at these rhombuses on both the left and the right. You can see there's only one diagonal drawn in. That's the way you're going to do it. Same thing with this other problem here. So 180 minus 66 gives you 114. And then you'll divide it by 2 because you're finding out either of the angles, any of these other ones here. So you divide it by 2. I actually ended up drawing in 4 things. I apologize if that's confusing. And you get 57. Now careful, it's asking you to solve for the variable, and it tells you that this variable is equal to that angle. Well, that just means then you have to write the equation. So after you do the math, if it's asking you to solve for a variable, set what you're looking for equal to your answer. Don't plug it in. Careful, it's not asking that. It's asking how big is that angle when it tells you how many degrees the angle is. So when you have one diagonal and you're trying to find angles, make sure you go through the math here of finding the angle and then set your algebra thing equal to that angle. So this comes out to be 3t is 135. And there's some Algebra 1 steps for the few of you who need it. And it's reasonable if you still need some Algebra 1 help. So hopefully these examples will be helpful. And I am looking to post those notes here after the Edpuzzle video. That should be the completed part. All right. Final page of notes coming up here. Instead of just one diagonal, what do you do if you have two diagonals? So first thing, even though I've said this out loud and it's printed on the page, what's different about these problems on this page compared to last page, compared to the previous page? What's unique about these pictures of how you'll do these ones different? And like I said before, there are two diagonals, like it's printed at the top of the page. Notice they've driven into four triangles. And yesterday in class, we did look that these four triangles are all right triangles. So even though there's not a box symbol printed in there, they are right triangles. So like we did on the first page, you're going to subtract not just the 33 from 180, but also the number 90. This can be confusing because on the previous page with one diagonal, we divided by 2. Here you just subtract twice, don't do anything special, and get your answer. That's this amount here. That's also the other angles you're looking for elsewhere. Not a lot of math to do. All right, on this next problem here, remember the key thing is in the middle, you mark a box. And so let me pause again. What's the math you do to start this problem now? That's right, you subtract from 180, not just the number 29, but even though the box symbol is not written in, you need to know when two diagonals are there, you have right triangles. So you divide, that's right, excuse me, you don't divide, excuse me. You subtract 90 also, get your answer. Now, what do you do with this answer when you're trying to solve for B? Because remember again, we're trying to find angle JGK. So I have correctly found this angle here, which is also the same as here, which is also the same as these two down here. And one of those two, if you trace the three letters, would be JGK. What do I do with the 61? And the answer is don't plug it in for B. No, it is you write the variables, what it's equal to, and it's equal to your answer of 61. All right, so at that point there, you just finish solving the problem. And luckily it asks you just what B is. It does not ask you to plug it back in like we did on page 2. It just asks you to solve it out. And we're all done with the problem. Now that you've finished this Edpuzzle, you're going to move on and work on IXL. You're going to see problems of all different types that are from these notes. Some are just yes, no. Do they match up with the pictures of the notes on page 2? Some of them are really simple questions about sides like page 2. Some of them are rhombuses with one diagonal on page 3. And some of them are rhombuses with two diagonals here on page 4. If you have any questions, you're welcome to send me an email, but please remember I'm not able to respond to emails live today. I will be online somewhere 3, 4, 5 o'clock in the afternoon. So at some point in time, I will get a chance to take a look at them. If that helps you, and then a response then will help you get farther on this before we see each other again tomorrow or Thursday, great. If that won't help, remember there's also live tutoring available through the HF webpage. Go to the students page. And there's tutoring on the middle of the page, and it tells you how to get access to a live math teacher from 3:15 to 4:45 and from 7 o'clock to 8 o'clock. These are all math teachers who teach the curriculum at HF. They're all very much aware of what we're doing and what's going on. Let me know if you need anything else. Otherwise, I will talk to you guys tomorrow or Thursday. Take care.